At 2:11 UTC on August 6, 2025, the James Webb Space Telescope captured a signal unlike anything in its archives. Not a comet's whisper of water vapor, not the dusty glow of an asteroid. This was structured metallic lines of nickel without iron, a violent surge of carbon dioxide and acceleration that defied every law of orbital mechanics. For hours, scientists stared at screens flashing numbers that should not exist. Then, without warning, the object fell silent. That final burst of data is all we have. And hidden inside it, some believe, is the comet's last message, the Midnight Alert. At 2:11 UTC on August 6, 2025, the James Webb Space Telescope recorded a spectral packet that froze mission control. Normally, Webb's near-infrared spectrograph returns clean bands of cometary gases, water, carbon monoxide, carbon dioxide. Instead, the screen lit up with a chemical storm. At the same moment, ground telescopes in Hawaii and Chile logged unusual tail behavior, CO2 flooding far from the sun, and metallic lines where no metals should exist. These signals weren't noise. They were fingerprints of something outside the rulebook. Within 6 minutes, Webb's entire observational calendar, weeks of scheduled exoplanet studies and deep-field galaxy surveys, was scrapped. The override protocol, used only 3 times in Webb's history prior to this night, redirected its full attention toward one target, 3I Atlas. Controllers watched as the billion-dollar telescope pivoted, slewing across the sky to lock onto an object smaller than 15 kilometers wide, but carrying implications larger than worlds. The urgency itself was historic. The first packets returned revealed spectral lines for nickel, sharp, unmistakable features at 3,415 angstroms and 3,524 angstroms. Yet the iron lines that always accompany nickel, always in every meteorite ever studied since 1808 when meteor iron was first classified, were absent. Scientists sat silent, staring at what looked like a violation of the universe's periodic table. A nickel-only comet is like a coin minted without copper. Not impossible, but unimaginable. By dawn on August 7th, the shock had hardened into dread. What astronomers had called a comet, a dusty relic from another star, was instead rewriting every expectation. Its ratios of carbon dioxide, nickel, and missing iron were more than anomalies. They were statements. For some, the phrase "final transmission" stopped sounding poetic. It began to sound literal. Atlas had spoken, and what it said made no sense. With the discovery came urgency. If Atlas was venting materials in defiance of physics, then chemistry had to be the next battlefield. What exactly was spewing from its surface? Was it ice sublimating, exotic molecules decaying, or a coded emission masked as cometary gas? The task fell to Webb's spectrographs and Earth's largest observatories. The world braced for answers. But what returned over the following days deepened the riddle. Atlas wasn't just strange. Chemically, it was chaotic. Webb's near-infrared spectrograph locked onto a spectral line at 426 microns, the signature of carbon dioxide. But the strength of the band stunned analysts. Instead of CO2 being a minor fraction of cometary outgassing, it dominated. Production rates suggested a CO2 to water ratio exceeding 8.1, the highest ever recorded. For comparison, Comet 67P Churyumov-Gerasimenko, studied up close by Rosetta in 2014, had a ratio below 1:1. Atlas was belching gas at levels so extreme that one planetary scientist at the Smithsonian Astrophysical Observatory called it like finding a steam engine powered by vinegar. Then came the metallic revelation. Observations from the Very Large Telescope in Chile and confirmations on Webb's ultraviolet channels showed atomic nickel emissions stable across multiple nights. But when astronomers searched the usual iron channels at 3,720 and 4,383 angstroms, there was nothing. This was unprecedented. In every iron meteorite studied since Widmanstätten patterns were first described in 1808, nickel and iron had been inseparable cosmic twins. Yet here nickel flowed freely, while iron remained invisible. Some chemists proposed exotic molecules as an explanation. Nickel carbonyl, NiCO4, a volatile compound that forms at temperatures as low as 43 degrees C, could explain nickel vaporization. Photons under ultraviolet light could strip it apart, releasing nickel atoms into space while leaving iron locked in more stable minerals. The idea was radical, but it fit the observed imbalance. Yet the question loomed, what nebular environment could forge so much nickel carbonyl in the first place? Not ours, certainly. The paradox cut to the heart of astrophysics. Comets are supposed to be time capsules, preserving the elemental recipes of their parent systems. For Atlas to carry nickel without iron was to declare itself an outlier, a messenger from chemistry gone rogue. If it was natural, it came from a star system with rules utterly unlike our own. And if it wasn't natural, the imbalance might be deliberate, engineered to send precisely this signal: I am not what you think I am. Chemistry alone was enough to unsettle the scientific world. But the strangeness did not stop at elements. When ground tracking stations over 72 hours noticed Atlas shifting against the predicted curve of gravity, attention turned from chemical impossibility to dynamical defiance. Something was moving Atlas abruptly, irregularly, and without any known force. Tracking stations in Hawaii, Spain, and New Mexico logged Atlas's position nightly against background stars. By August 9, 2025, calculations showed a disturbing fact. The object was accelerating. Over a 3-day span, velocity had increased by roughly 0.12 meters per second squared. For an 11-kilometer wide body, this was enormous, the equivalent of a cruise ship accelerating at freeway speeds with no engines. Outgassing, the usual culprit, couldn't explain the magnitude, especially given Atlas's unique CO2 profile, but the real shock was in the rhythm. The acceleration wasn't smooth. Superimposed on the overall increase were sharp microjumps, each lasting tens of seconds layered like pulses. Data from the Pan-STARRS network confirmed the pattern. Instead of a comet venting randomly, Atlas behaved as though something inside it were firing in bursts. Like thrusters, one Caltech researcher muttered, words that would later appear in a leaked internal memo. Orbital mechanics team scrambled. Radiation pressure from the sun was too weak. Asymmetric jets were possible, but the timing was far too regular. Even after running simulations across 500,000 test scenarios, no model reproduced the observed acceleration with natural causes. The conclusion was impossible to ignore. Atlas was being pushed, but by what? By August 12th, telescopes from Chile's Gemini South Observatory and NASA's TESS satellite reported something extraordinary. Atlas's brightness variations followed a precise 7.2-hour rhythm. This wasn't the ragged light curve of a tumbling comet. The graph looked like a metronome. Sharp rises, steep drops repeating with machine-like accuracy. Outgassing should have altered the spin, slowing or accelerating it randomly. Yet Atlas held steady as if immune to torque. Each peak resembled the sweep of a lighthouse beam, a flat reflective facet turning toward Earth, then away again. Astronomers ran light curve inversion models and found that only highly geometric surfaces, panels, sheets, or internal scaffolding could produce transitions that crisp. Normally, rotational periods shorten or lengthen as comets shed gas. Atlas venting CO2 at unprecedented rates should have wobbled wildly. Instead, its spin remained locked as though countered by internal stabilization. Some suggested it was hollow, balancing like a gyroscope. Others pointed to Oumuamua's odd light curve in 2017, which also resisted tumbling. But where Oumuamua left open questions, Atlas delivered definitive patterns, mechanical, unyielding clockwork. Privately, a few dared to ask the unspeakable, could this be engineered? A rotation held to a timetable, acceleration in bursts, and chemistry that resembled no comet ever known. The lighthouse hypothesis that Atlas flashed deliberately like a signal beam crept into memos. Out loud, scientists stayed cautious, but in closed-door briefings, they called it what it looked like: artificial precision.